that there is three dimension that the electron can move through them. So it make a high contribution in discovering what? In discovering the electron. Okay, what else? The last one here, we have what? We have Heisenberg. Werner Heisenberg here from 1901 till 1976. What is the contribution of Heisenberg? Okay, he refused before everything that taken before. Okay, so I'm not sure about anything that you have coming to me, and we can call it what? Uncertainty principle. It means that you can't mention which the position or velocity of electron at the same time. Okay, so it make or put a principle that we called it uncertainty principle of the Heisenberg. Okay, so it mentioned that both the position and the velocity of the electron can't be both be measured at the same time. I can't, I can't measure it. Okay, I don't know where is you. Where are you? Where are you here? Depending on velocity and what and the position. Since you could never, with great certainty, measure more than one property of the particle, we mentioned that you could only work with the probability and mathematical formulations, and we make also a kind of words, we called it uncertainty principle of Heisenberg, and it depends on a fact here, not some suggestion or some conclusion. Okay, so if we make a compare, we want to make a compare between some words that we use. What is the difference between law and theory? What is the difference between them? Okay, here we have scientific law means set of observed regulations expressed in a concise verbal and or mathematical statement. We have here some conclusion depending on the that we observed or that we taken from the experiment. Okay, and also we put it as a statement. Particular phenomena always here occur if a certain definitions or a certain conditions are present. If the certain conditions are present, we can apply this law only. We have here the scientific law. Another one describes what nature does under certain conditions or predict what will happen. Okay, it make a fact. It means it is a fact. The last one here, it resists changes over time. It means that if we have the law, like the density of law, okay, we have the density law. Density, it is the mass of a unit volume. So the rule here or the law that making from the density, if we have the mass and the volume, we can by applying the rule density equal mass over volume. So we can applying the rule or law here. It is a scientific law, not changes with time, not affected by changing time. Another one here we have the theory. What is the meaning by scientific theory? It's a explanation or observation for an observation or series of observation that is sustained by considerable body of evidence. Okay, we mean that if we make some experiment, we make theory or put assumptions that make this available or make it present, or we can apply it if you make this observation or explanation for the steps that you make in your activity. Another one, body of knowledge and explanatory concepts that seek to increase our understanding. Okay, if we want to make an explanation for any phenomena in nature, that we will return back to the theory of it. We wanted to know the theory of discovering the gravity, like Newton law. Here we have the law that discovered by Isaac Newton, and also the theory explains what is the behavior that leads to discovering or to giving the law at the end of it. Okay, the last one here, it explains how nature work. How nature work make availability to what to change over time. But if we have a law, it's not affected by changing time from previous years or previous centuries until now. Okay, so what about models? Okay, we said each scientist make a model or constructed to help explain complex concepts. We have each one make discoveries or make concepts regarding to what? Regarding to the atom. So if we make a model, it means that we explain what discover in some points or some statements that illustrate its discovery, but in a simple way. Okay, if we have models, I collect all the models according to the questions. That very important. I think it's very important, not much more than expected. Here we have the first one, Rutherford model. Okay, Rutherford model. When you look at the picture in front of you, we have here nucleus and the electrons surrounding it. Picture the atom as a mini in nature, like what? We have here center nucleus and surrounded it by the nucleus. Surrounded it by electron. So here we have solar system, like the sun in the center and planets revolve around it. Okay, it is some similarities between both system, with electrons moving around the planets or like the planets. So we have electrons similar to planets and nucleus similar to what? Nucleus similar to sun in the center of the solar system. Okay, another model we have here, Bohr model. What is the difference between them? Okay, it is a quantized. It make a model depend on the quantity or the quantum model of energy. We said that we have a quantized model that the orbit any electron explains the stability of the atom. It means that each electron has its own quantized energy or quantum of energy that make it in this place and can't move or can't be in another place that has a special or quantum of energy or quantized energy that make it special for Bohr model. Another one here we have what? We have Schrödinger model. Schrödinger model means that we have a bounded idea of precious orbit. This means that before Bohr, or it replacing them with description of regions called orbits. He measured the one, we called it orbitals. Orbitals, electrons were mostly found inside it, but we can't say that he discovered the energy levels. He discovered the orbitals that the most probability in discovering or the most probability in finding what electron. If we take these orbitals containing electrons with various values of angular momentum or region of a space, like this shading here, we have the shading area, shows the probability of finding what? An electron at that distance. Okay, so we have here three models explaining what the electrons distribution. We have Schrödinger model, we have Bohr model, and the last one we have Rutherford model. Okay, we have another concepts that we discuss here. We said we have two different points. We have what? We have law and theory. What is the difference between them? If we have the scientist Isaac Newton, mention or discover what here of gravity? Law of gravity. Law of gravity. Okay, this is means that gravity described as is not explained in terms of how its probability came about. So gravity is a concept or a fact that present, not maybe increase or maybe probable. No, it's a fact. Here it a fact, not probability. So here we have gravity. What is gravity and why is there gravity? That make it a law at the end of what? Of discovery, that we have law of gravity. What and why? What is the gravity? It means that attraction force that make from the earth to the bodies above it. And also why there is a gravity, as we said before, that we have some metals, heavy metals inside the earth's crust or inside the bottom of the earth that make the gravity present as well. So it is a fact that make the law of gravity. Okay, we will make some practice or some exercises for the all the concepts that we have taken before. Or if we take that, the law of gravity describe what? Describe the relationship between two masses. The more massive an amount is, or the closer it to the another body, the more the gravitational attraction force between the two objects. So the law limited here, the law is limited, limited or depend on the fact between mass of object or two bodies and distance between them. But because it can't explain any of the following. Okay, it can't explain which of the following. The first one, what gives the larger object more mass? Why we experience gravity on what? On earth and not in space? Why there is a gravitational attraction in the first place? Why does the smaller object also attract larger object? We will complete the answer here. The answer will be why there is a gravitational attraction in the first place. Okay, it means that we have here only one point that explain the what? Explain the law of gravity. It means that depend on the fact, and the fact is what? The presence of gravitational attraction force in the earth to the bodies that present on it. Okay, this we called it what? Law of gravity. So we mentioned the relation between mass and what? And distance between the object, and we will conclude or make it as a law of gravity at the end of discovery. Here we have what? A model. What is this model called? We have a lot of questions. I collect some of the important questions for you, and I think it's main kinds, not only the choose or MCQ questions. We have here what is model in front of you. We have the model, we called it Blum Budding model. Okay, who created this model? Thomson or Gigi Thomson. What is he most known for discovering? What is he most known for discovering? Or what is assumptions? It means that what is assumptions depending on the drawing in front of you. If you don't know, depending on the drawing in front of you, here we have the first one, discovering as all the behavior of electron, or it depends on the discovery of the electron. Okay, who disproved it? Who disagree or disproved the discovery of Thomson? The second one come after it, that Rutherford neglected or disproved or cancelled, that discovered by what? By Gigi Thomson. Okay, which experiment disproved it? Okay, which experiment it make what to make or to explain the plum pudding model, we said that we have what we have